Assalamualaikum warahmatullahi wabarakatuh. So I will explain for question number 1. So for number 1, we need to find force in each of the members of the truss, and we need to state whether it is tension or compression. First step we need to do is draw whole free body diagram. So as we know, at point A is a fixed point, which is we have two directions which are AX and AY, and on point G we have roller at there, so we have one direction only, which is GY. So first thing is we can find moment on point A. So we draw a vertical and horizontal line so that we can see the force is perpendicular to the distance, and we assume that counterclockwise is positive. 50 kilonewton is clockwise, so it is negative. So negative 50 times 3. Also with this, negative 50 times 6. Okay, 3 plus 3, and same with this. And for GY, it rotates to the counterclockwise, so it is positive. G times 18, and we got GY equal to 50 kilonewton upward. Next, we do a equation total Fx equal to 0. So Fx on the free body diagram only have Ax only, so Ax equal to 0. And for total Fy equal to 0, we have Ay, Gy 50, 50, 50. So Ay we got 100 kilonewton. Second step is we find force on point G at here. So there is Gy, FGH, FGF. So still the same step. Total Fy equal to 0. So we have Gy and FGH, and we will got Gy plus FGH. FGH equal to negative 50 kilonewton, and it is compression. So it is compression, it will look like this. So for total Fx, we only have FGF. So FGF equal to 0 kilonewton. Next step, we find force on point H, which is at here. So there is FHI, FHF, FGH. So we need to find theta. So this is this is 3 meter and this is 4 meter. So we can find the angle. We got 36.87 degree. For total Fy equal to 0, we have FGH and FHF cos theta. Okay, so FGH we already got it here. So 50 minus FHF cos 36.87 degree, we will got FHF equal to 62.50 kilonewton tension. Since it is positive, so it's tension and it is the right direction. It's still the same step. Total Fx equal to 0. So Fx we have FHI and FHF sin theta. So both of them is to the left, so it is negative. And we will got FHI equal to negative 37.50 kilonewton compression. So like this for FHI. Next step, we do a cross section, which is at here. We cross it. So and still the same. Total Fy equal to 0. So this is Fy and this. So 50 plus FFI. So we got FFI equal to negative 50 kilonewton compression. So FFI should be look like this. For total Fx equal to 0, we have FFE and FHI. So FHI we already got here. So just put the value minus FFE, since it is to the left, and we will got 37.50 kilonewton tension. Okay, next step on point I. So total Fy equal to 0. this is FFI and FEI cos theta. Both is downward, so it is negative, and we will got FEI 62.50 kN tension. And for FX also, we have FIJ, FHI, FEI sin theta. So we will got Fij equal to negative 60 kN compression. Okay, next step we do a cross section on here. We will get like this. Fej is equal to Gy. Fej equal to FFI, FGH, and Gy, which is 50 kN compression. And for total Fx equal to 0, we have Fed and Fij. So we already have Fij. We just put the value inside the equation. So we got 60 kN tension. So we will do like this. Okay, next step is we do a section. So FJD equal to FEI, she said here. So it is the same value of force. And total Fx equal to 0. We have Fed, FJK, FJD sin theta. So all of them is negative sign because to the left. So we got FJK equal to negative 97.50 kN compression. Step number 8, we do a section on the left hand side. So we find a moment on point L, which is at here. We draw a vertical line and horizontal line. And we got 100. 100 is AY, and the distance is, is perpendicular. The distance is 3 plus 3. We got 6, and it is a clockwise rotation. And we have 50 times 3. It is counterclockwise, which is positive. And FCD, which is counterclockwise, which is positive, times 4 here the distance, and we will get FCD equal to 112.50 kN tension. Okay, for total Fy equal to 0, we have FLD cos theta 50, 50, and 100. So put it to this equation. We got FLD equal to 0 kN. Okay, for total Fx, we have FCD, FLD, sin theta, and FLK. And we know FLD equal to 0, just cross it. And we got FLK equal to negative 112.50 kN compression. So it will look like this. Alright, so that is the halfway of the calculation.
So for the next step, we can do at the moment C, and we assume counterclockwise is positive. So we can see that 100 is clockwise, 50 is counterclockwise, and FML equal to clockwise. So we can get the negative 100 multiplied by the distance is 6 plus 50 and multiplied by the distance is 3 minus FML multiplied by the distance is 4. So we can get the final for FML equal to negative 112.50 kN, and it is compression. So we can find the Fx equal to 0, and we assume at the right is positive. So for this rigid body, at the Fx, we can see that we have FML negative 112.50, and we have FMC sin 36.87, and we have FBC. So we can get the FBC is equal to 112.50 minus FMC sin 36.87. For the next, we find the Fy equal to 0. So we can assume that at the up is positive. So we can see that 100 is up, so it is positive. 50 is downward, so it is negative, and FMC cos 36.87 is downward, so it is negative. So we can find the FMC is 62.50 kilonewton and it is tension. So when we get the FMC, we can replace it at the FBC. So FBC equal to 112.50 minus 62.50 sin 36.87. So we get the FBC is 75 kilonewton and it is tension. At the point C, we need to find for this degree. As we know, this is 90 degree. So 90 degree minus 36.87. So we get the 53.13 for this degree. And we need to find Fy equal to 0. So we assume to the up is positive. We can see that this rigid body, we can find the FCL is up and it is positive, and FMC sin 53.13 degree is to the up and it is positive. So we get the FMC is 62.50 kilonewton, and we replace it with the answer, and we get the, when we move to the right, we get the negative 62.50 sin 53.13. So we get the F for FCL is negative 50 kilonewton and it is compression. At the point M, we can find the Fx equal to 0. So we assume to the right is positive. For this rigid body, we can see that FML is negative 112.50, and we have FMC sin 36.87, and this is to the right, so it is positive, and we get the FMN and it to the left, so it is negative. So we can find the FMN, and we get the FMN equal to negative 75 kilonewton and it is compression. So for FMB is equal to FCL, and we get the negative 50 kilonewton and it is compression. For the last step, we can find the Fy equal to 0 and Fx equal to 0 for this rigid body. So we find the Fy equal to 0. So we assume to the up is positive. For this rigid body, we can see that we have 100 and is up, so it is positive, and we have F and B cos 36.87, so it is negative because it is downward. So we can find the F and B is equal to 100 divided by the cos 36.87. So we get the F and B is equal to 125 kilonewton and it is tension. For the Fx equal to 0, we assume to the right is positive. So we can find at this rigid body, we have Fmn is equal to negative 75. We have Fmb sin 36.87. It is positive because it is to the right, and we have FAB and it is positive because it is to the right. So we can get the FAB is equal to 75 minus 125 sin 36.87. So we get the FAB is 0 kilonewton. So we can get the final answer for FGH, FFI, FEG, FCL, FMB and FAN equal to 50 kilonewton and it is compression. For FGK equal to FAB and we get 0 kilonewton. For FHF, FEI, FJD, FMC equal to 62.50 kilonewton and it is tension. For FHI equal to 37.50 kilonewton and it is compression. For FFE equal to 37.50 kilonewton and it is tension. For for Fig equal to 60 kilonewton and it is compression. For FED equal to 60 kilonewton and it is tension. For FJK equal to 97.50 kilonewton and it is compression. For FCD equal to 112.50 kilonewton and it is tension. FLK equal to 112.50 kilonewton and it is compression. For FBC equal to 75 kilonewton and it is tension. For FMN equal to 75 kilonewton and it is compression. For FLD equal to 0 kilonewton and the last one is FNB equal to 125 kilonewton and it is tension.
Question 2, we need to find the reaction at B, C, D and force at A. So here we have a rigid frame with applied force support at A, B, C, D. Point A is a fixed support. Point C and D is a roller and point B is a rest on a flat surface. So there is have 480 forces, horizontal forces and applied at point E. So to solve the reaction, we need to apply the three condition equilibrium, which is the sum of Fx equal to 0, the sum of Fy equal to 0 and the sum of moment equal to 0. These three we need to apply first. So for the first step, we need to do the free body diagram at point A, B, C, D. After that, we find a moment at point B, which is equal to 0. Point B, 480 and the distance is 80 minus dy and then the distance is 120. So we calculate it, we get dy is 320 kilonewton. So the second step at point B, we find the sum of Fx is equal to 0 and 480 which is at x axis minus bx equal to 0. So bx we got 480 to the right, and for Fy equal to 0, so dy we got from here, dy is equal to 320. So for by we got negative 320 downwards. For point A, Fx equal to 0, Ax plus 480 we got from here. And then Ax equal to 480 to the left. So for component y, Fy equal to 0. So Ay minus by minus cy plus dy. So Ay equal to by plus cy and minus dy. So 320 plus 800 negative 320, we got 800 upwards. So after we find the force at point A, we do the moment at point A. For moment at point A, we use clockwise as a negative or anti-clockwise as a positive. So the sum of moment at A equal to 0. So negative 480, the distance is 40 minus by minus bx minus cy, the distance is 160 minus dy. So negative, we sub all the value that we already find. So we got cy equal to negative 800 downwards. For the final answer, we got by equal to 320 Newton downwards, bx 480 Newton to the left, ax 480 Newton to the left also, and ay 800 to upwards, and CY, we got negative 800 to downwards.
The question 3, determine the force P that exerts on the twig at E. So actually the P was here. P. So first we divide by two sections. First section is this one. Second section is this one. Why we choose this one and this one? Because of the connector on PC, they connect the section 1 and section 2. First, we have to draw the free body diagram on this part, FPD on this part. So we have point A, we have point A and point B. So at the point A we have AY and AX. This is force. And at point B we have PC, BX and BY. So the solution on the triangle to have the solution on this one. And then what we're gonna do is do the moment at A, and I'm assume that counterclockwise is positive. So at this 100 Newton was positive, Px is negative, and By also negative. And this is the solution, the equation of the solution. And we got the FBC is 661.1 Newton. Okay, the second section we have to draw FBD on this part. So we have the point D and the point C. We have dy and we have dx. We have the exit on E is E here, and we have cy, cx and fcb. This is the solution on the triangle. And then we have the cy force, cy and cx. So actually FBC is equal to FCB. So we have the number. So the force is minus 0, 1. And this is the solution. We can do that at moment D. At moment D, we assume that counterclockwise also. Counterclockwise. This one counterclockwise. So the CY is positive, CX is positive, and P is negative. This one is clockwise. So the solution was here. This is P is negative, CY and CX false. And we already have the FPC. Change here. And now we got the exact P on tweak E 825.27 turn. So actually the force was here.